visualisation tools for spatially integrated social science data. Dr. Ward is based in the e-research lab at the School of ITEE at the University of Queensland. He's currently managing UQ's ANZ-funded Seeding the Commons and data capture needs. As part of his current role, he's investigating semantic web approaches to representing the research data context and research-oriented interfaces to metadata registries.
Okay, thanks Leslie. What I'd like to talk about in the next 20 minutes are some tools that we've built within the University of Queensland, looking at combining social science data, particularly census data, demography and socioeconomic data, with voting patterns data, and using geography, tools that use geography to combine those heterogeneous data sets. So what I'm going to do is give you a demo of a tool that we've built, hopefully explain how we built the tool, and by the end of the talk I'd hope you've got an understanding of how that tool might help social scientists work more effectively. Like any good talk, it's got 3 sections. I'll give you some background, some context for why we've done this work, dive into the meat of what the data is that we're analysing here, the tools that we've built to look at that data, give a demonstration. If I'm brave enough, it'll be a live demonstration, have a look at how we built the tool, what the architecture is, and then reflect on the experience. So the background is this is a project that's been funded by the Australian National Data Service through the Data Capture Project. It's a collaboration between our team in the e-research group in the School of Information Technology and Electrical Engineering, and a group that's currently working in the UQ Centre for Population Research, but has previously come from the UQ Institute of Social Science Research. That team, Paul Shai, Irfan and Friska, and Jane Hunter actually got a previous ARC grant to build a prototype for this tool. That prototype was mainly built on closed source technologies. So a lot of what this project's done is actually open them up and build the tool on open source technologies and integrate new data. The tools I'm going to demonstrate work broadly in the field of what this group calls spatially integrated social science. And they characterise that as a field of endeavour where they recognise that much social science data actually has geography associated with it. And the theory is that you can use geography to mash up quite heterogeneous data sets that previously you couldn't really find common variables in. And what we're going to demonstrate today is socioeconomic data, demographic data from the census, and voting data from the Australian Electoral Commission. So as well as using geography to integrate that heterogeneous data, we can use it to help visualise patterns in the data we might not have previously been able to see. We can also use geography to filter the data, so to say that I only want to look at data for regional Victoria, for instance. The objectives of our ANZ project were threefold: to build some tools to help these social scientists look at the data I mentioned, to expand on that existing prototype, in particular to move it from a closed source system to an open source system so that others could build on it, to incorporate new data into the tool. So since the prototype was built, we had a federal election. We've integrated voting results from that into the tool. And thirdly, to syndicate information about the variables we're analysing in the tool to ANZ Research Data Australia, because it was an ANZ-funded project. At the end, I'll reflect on the experience of trying to describe this data within ANZ. Okay, so what's the nature of the data? I've already mentioned it's the 2006 census, so we're getting demographic data, socioeconomic data from there. It's Australian Election Commission data. I'm going to show you 2010 voting results from the federal election, but also from the Australian Election Commission, we actually get locations of polling booths. Paul Shai with our research team, he takes data from the ABS and AEC. He mashes it up to create variables that he wants to perform statistical analysis on. So it's not just the raw data, it's derived variables from the data. It's things like not just what percentage of people in Melbourne ports voted for the coalition, it's what's the comparison of that percentage compared to the national percentage. So he's created derived data. Additionally, most of the work that Paul does is align these variables with these geographies. And there's 5 levels of geographies this group deals with. Levels 2, 3 and 4 there we get from the ABS. They're census-related geographies. Statistical local areas, local government areas, and urban centres. At the top there, we've got a geography that's been created within UQ. It's called a polling booth catchment. So they've analysed the location of all the polling booths in Australia and created a likely catchment that people have come from to vote at that polling booth. So a little polygon around a polling booth of where people have probably come from to vote. The other end, we've got a geography that's come from the Centre of Full Employment and Equity at the University of Newcastle. It's called a Functional Economic Region. That's somewhere like the Pilbara, a massive region that has an economic kind of centroid, I guess. So these 5, so what a lot of the work that Paul does is map these 5 geographies to those variables that he's derived. Additionally, he describes those variables. So he talks about the provenance, where they've come from, how he's derived them, what statistical name he wants to use them for, and how we might display them in our tool. And I'll explain why that's significant later. So I'm going to be brave and do a live demo. I got Paul to give me a dumbed-down hypothesis I might test with the tool, which is that Labor gets more votes than the Coalition from low-income households. So let's see if we can use the tool to analyse that. Internet permitting, here we go. So the first thing I need to do within the tool is select an area that I want to analyse the data in. I'm going to analyse data for Melbourne Ports because that's the electoral division we're in. So that will zoom the map to Melbourne Ports. I can say where are the polling booths in Melbourne Ports, you can see them there. I can put labels on those, I won't because it will clutter the map. The next thing I do is choose some variables to try and see some trends in the data that supports my hypothesis. So what I've done there is ask the tool, what I will do in a tick is ask the tool to give me all of the polling booth catchments with low income, or map the polling booth catchments according to income. So it's gone away and done that. And you can see the darker regions are the lower income regions within Melbourne Ports. The next thing I'll do is compare that to the voting results. So what it's done now is, for the polling booths, is mapped which polling booths had Coalition about equal to Labor, which was the grey, Coalition more than Labor, which is the blue, Labor more than a Coalition, which is red. So the idea is from this, social scientists can see some trends in the data that maybe low-income households do vote for Labor more than the Coalition in Melbourne Ports. So maybe it's worth doing some statistical analysis. That's the next phase of the tool. There's a bunch of statistical analysis techniques we've got. I'm just going to show you regression analysis here. So what I'll do is say, give me all of the Labor, Coalition, and I'll throw green votes in as well. In low-income households. And it's run some R routines there to do some statistical analysis. So once again, this is low-income households in Melbourne Ports, and that's saying it is more likely that they will vote Labor than the Coalition. It's also less likely they'll vote Greens, which is an interesting trend there. So a pretty simple hypothesis, but it gives you an idea of the power of this tool. Okay, what I'd like to do now is just explain what we've built. How are we going for time, Wesley? 10 minutes, okay. As I said, it was previously built on proprietary tools, ArcGIS, things like that. We weren't sure at the beginning of the project whether we could rebuild it with using open source components. We've managed to. So at the bottom there, we're using Postgres as a database with PostGIS geospatial plugins. Following the middle path there, that original classification where I was drawing colours on the map, that's done using a classifier which is written, a bespoke bit of code that's written in Java. It serves the maps up through GeoServer, which is an open source server for serving map tiles essentially. The presentation is done using two JavaScript libraries, OpenLayers and GeoExt. Following the right-hand path up there, the statistical analysis is done in R using, and we talked about using something called RServe. I only showed you regression analysis, but there's a bunch of other techniques that the team has put together. Originally in the prototype, the R would actually output graphs and we would display those. We found that a little bit flexible because it was hard to change the colours, do kind of Web 2 kind of stuff. So what we've changed the architecture so that the R actually outputs a format and we interpret that in JavaScript. We're using a toolkit called processing.js to do that. That was an interesting choice because processing.js has usually been used by the creative arts community to create kind of funky web things, but we found it a pretty good fit for our tools. Over on the left-hand side there, as I mentioned, we actually describe the variables in the system. The interface you saw is totally driven off the variable descriptions in the database, so nothing is hard-coded into the interface there. So we have information about the variables served from the database, and jQuery interprets those and dynamically creates the interface. And I'll come back to why that's important later. So it's a pretty interesting tool and a pretty amazing tool, I think. However, there's still a number of challenges left outstanding. One of them is that getting data in is still a very manual process that uses proprietary tools. So the data we get from ABS and AEC, we get in something called shapefiles. You need a GIS system. Paul uses ArcGIS to interpret that, pull it apart, and integrate it with the CSV files. So the data integration, variable extraction, and geographic associations, labour intense and still relies on proprietary tools. So I think that's an ongoing challenge. The metadata we use to describe the variables, we wrote our own schema for that. We don't think that's the right approach. We're interested in advice about how we might describe our variables so we can generate an interface and generate statistics. So looking for advice there. I mentioned that one of the goals of the project was to syndicate collection descriptions to ANDs. So the system already has descriptions of the variables, the provenance, the statistical name, the display name, that sort of thing. However, when you look at those descriptions, they're far too big to put into an ANDs description, in my opinion. ANDs is looking for more a generalist, abstract description, saying, you know, this is socioeconomic data and voting data, information about income, religion, that sort of thing. So we haven't managed to rationalise those two views of the data within the system. We have an internal view and a view for ANDs, and we're just having to live with that at the moment. And yeah, be interested in people's feedback about whether that's their experience as well. One of the reviewers of the paper brought up the issue of rights, and rightly so. So the original census data and the voting data, that's all open data we can get from the ABS and the AEC. However, the derived data, the variables we've created, and the associations with the geographies and some of the geographies themselves, we haven't managed to convince the researchers that they should be made openly as well, even though they're derived from open data. Sure, that's a common discussion you're having in your institutions as well. They see it as their IP, so that's an ongoing discussion we have that, you know, this is publicly funded, maybe you should have put it out there. So at least we've got open tools for people to analyse the data. We currently don't have open data, and that's an ongoing challenge. The final challenge I've put up there is scalability. What if this is really successful? Can it deal with 1,000 researchers hitting it within a minute? That's an unknown question, but one we will be investigating. Yeah, can we design it so we succeed? Opportunities related to those challenges. The tool we created is very generic. So if any data that meets the CSV format associated with one of those geographies can be displayed in the tool. So we're interested in using it to visualise and analyse other data. And the biggest opportunity there is we're in very in-depth discussions with the Australian Urban Research Infrastructure Network being run here out of the University of Melbourne to include our services and variables into their